Hello, I'm Ivan and today I'll be reviewing the energetic PEI spring steel sheet with magnetic base. So I'm using this for more than 6 months and I can say it's quite a durable product. For all this time I didn't see any degradation, neither mechanical or in its properties. There are some marks here, as you see, of different parts, but this is because of the nozzle being too close to the bed. But there's no any impact on the filament adhesion in these areas. So this product is sold in many different sizes to match most of the printers and in different variations. Like for example, if you have already magnetic bed, you can buy just the spring steel sheet that can be one side or two sides like the one I have. If it's one side, you can choose between a flat side with PE folio or textured side with PEI coating. And when you have both sides, okay, you have one flat, one textured side, which gives different finishing on the parts. This is a part printed on the flat side, so it's completely flat, and this part here has been printed on the textured side, so you see the kind of finish you will get. So in this video I will show you the installation and tests with different filaments. We'll see what materials print well and what are the optimum settings. And at the end of the video I will show you how I made my own polycarbonate steel sheet in order to use the magnetic bed with a different printing build plate. If you buy the complete set, you will get a magnetic sticker to apply to the aluminum hotbed of your 3D printer and a double-sided spring steel sheet. I have CL10 and I bought 310 by 310 mm plate, which is quite large. It costed me around 45 USD. Before installing the magnetic sticker, clean the aluminum bed with 99% alcohol to assure better adhesion. The magnetic sticker installation is similar to installing a screen protector on your phone. Peel the protective paper of the sticker at one end, align it to the hotbed and fix it. Then progressively peel off the protective paper while chasing the air bubbles with your other hand. Once the magnetic PEI bed installed, you can print right away. I would recommend though to leave it for few hours so the adhesion takes better effect. You can also put something heavy on it, like few books. Now let's test the PEI surface with few common filaments. First is PLA. I'm not very much in the PLA printing because I print mainly functional parts from ABS. So I printed two small PLA objects, a calibration cube and a benchy. The calibration cube printed fine at 50 degrees Celsius hot bed temperature. Taking the print out was easy when the print bed cooled down. Energetic claims you can print PLA even without heating the bed. I tested this by printing a benchy and it printed successfully. However, I found the adhesion to the bed too weak and I don't recommend this for large prints. So 50-60 degrees Celsius bed temperature seems fine for printing PLA. For PETG, I printed a large part, the measuring cube. First, I tried at 70 degrees Celsius hot bed and the part didn't stick well, resulting in failed print. I increased the heated bed temperature to 85 degrees Celsius and this time the part stuck perfect. So the optimum hot bed temperature for printing PETG is around 85-90 degrees Celsius. Now I tested extensively the PEI sheet with ABS, this being my main filament. I printed several parts with different geometries, with and without raft, solid and large parts, and I can say this build surface is excellent for ABS. You need to maintain the hot bed temperature around 90 degrees Celsius for perfect adhesion. Compared to a polycarbonate sheet, which is my other preferred build platform for ABS, the PEI is more energy hungry because the ABS prints at just 80 degrees Celsius on a polycarbonate surface. However, the PEI brings more convenience, easier part removal and more precision when printing functional parts. So this part is about to finish successfully. It was one of the largest part I ever printed from solid ABS 100% infill, and the paste steel sheet did great. I mean, it could hold the part during 8 hours of print. Well, you need a heated enclosure for this. The temperature inside is 45 degrees Celsius, which prevents the ABS from shrinking and bending when the layers cool down. But still, such large part from 100% infill ABS stayed perfectly straight during the print, and I'm very happy with the PE steel sheet. Yeah. If you wonder what these big ABS parts are for, search for Swiding Legulini on Thingiverse. It's a pump action bow with up to 6 arrows, and I had a lot of fun assembling and playing with this toy. Okay, so far we saw that the PEI sheet is great for printing POA, PETG, ABS as well, and now I'll be testing it with PC ABS. This is polycarbonate with ABS, and it has become one of my favorite filaments for functional parts. It's normally a filament that prints easier than ABS and much easier than polycarbonate, providing great dimensional stability. And the issue I had with this filament in my previous build surface was that it sticks too hard to the polycarbonate sheet. As you see, it resulted in broken sheet, and there are some parts that broke but couldn't be removed from the sheet. So I count very much on the PEI sheet to be more performant with PC ABS, and it is. I'm working on building a Voron Core XI printer, and I print all the parts from PC ABS. The PEI bed assured very good adhesion for this material, but also perfect dimensional precision. When precision is important, you can't use the textured PEI powder coated side, because it adds 0.5 mm to parts thickness on the Z-axis. It was quite easy to remove all PC ABS parts from the PEI. Printing polycarbonate on the PEI failed miserably at 100 degrees Celsius hot bed. Some people say polycarbonate prints just fine on PEI sheet at temperature of 125-130 degrees Celsius in the hot bed. I cannot reach this type of temperatures with my current PCB heated bed, so my option is to install this type of silicone heater that is supplied by the main voltage. You see 220 volts here in Europe or 110 volts in US, and it has a power of 750 watts. So this heater heats up very quickly the bed. It's very powerful, but I have serious safety concerns about installing this type of equipment on a Cartesian printer with moving bed. So I will keep this for another project. What I will try is to use a normal polycarbonate sheet, which I know is great for printing polycarbonate at just 80 degrees Celsius. I have a dedicated video for this building surface on my channel. So I will try to use it with my new magnetic hot bed. Let's see how. Well, the basic idea was to make a metal holder for a 3mm polycarbonate sheet, so I can use the PC surface on the magnetic bed without fixing it with paper clips. I took some old 1mm thick steel sheet lying in my basement and cut it to hold the PC sheet. It was quick and dirty make, but did the job. My new magnetic PC sheet is quite heavy, adding almost 600 grams to the hot bed, so it cannot be used at high printing speed. This is okay because the PC filaments print at 25-30 mm per second anyway. I could make it smaller and lighter because most of the time I print small polycarbonate parts. No surprises here, the PC part printed fine at just 80 degrees Celsius hot bed. So in conclusion, I can say that this is a must-have for any 3D printer. It excels with most common filaments like PLA, PETG, ABS, also with PC-ABS. And the magnetic bed brings a lot of convenience. It's easy to take out the print, no more paper clips, and this is a flexible platform. so you can remove your prints quite easily. For other filaments, like polycarbonate, you have either to increase the printing temperature if you want to use the PEI sheet, or you might have to use a custom built plate, and for polycarbonate I recommend to use polycarbonate sheet. So thanks for watching. There are some links in the description if you want to buy the product, and see you next time. Bye bye.